Alright, so today we are doing a lab on ionic and covalent compounds. I'm going to kind of read you guys through the lab and then walk you through it so you could do this lab assessment for this unit. So basically the introduction is ionic compounds are formed with metals and nonmetals, and covalent compounds are when they are all nonmetals, which we talked about in this unit. The materials that we'll be using today is some aluminum foil, a ring stand, an iron ring, and a Bunsen burner. The chemicals we'll have is sodium chloride or salt, sugar, and then there's 4 unknown compounds. So before we get started, for the pre-lab, the formula for table salt is NaCl. In the digital notebook, you need to put if that is ionic or covalent and how you know. And then the formula for table sugar is C12H22O11. Is that ionic or covalent and why? There are also charts below that you'll need to fill out throughout this lab. The first one is when we are talking about the salt versus sugar, and then the second one are the 4 unknowns that we'll talk about. So based off of this, you will be able to answer the conclusion questions and fill out the chart for this lab. The first thing we're going to talk about to fill in for salt versus sugar is the relative melting point. Which one melts faster, which one melts slower. So I'm going to put the camera right above here so you can watch what's happening with the Bunsen burner. Alright, so step 1, I cut a piece of aluminum foil that is big enough to fit on the ring stand. We are going to set the ring stand up with the iron ring attached, just like this. I'm going to move it up just a little bit so it's not as close to the flame, because you want it to be about 3 to 4 inches above where the flame's going to be, so it's not directly catching on fire. So here I have the aluminum foil. You notice that I did label salt and sugar so we can keep an eye on which one melts first, which one has a relatively high or relatively low melting point. Then I'm going to put just like a pea-sized portion of sugar. Right on top of the sugar where I wrote the word sugar. And same with salt. So now I'm going to light the Bunsen burner and adjust the flame height so the tip of the flame is about 1 inch or so below the aluminum foil. And then we are going to watch and see which one melts first and about how long it takes for it to melt. Do need to lower the ring stand just a tad bit. So you can see the sugar is starting to smoke and melt and turn yellow, whereas the salt has not really changed much. So in the chart you can say that sugar has a relatively low melting point because it has not even been a full minute and it is already boiling, and then salt still looks exactly the same. There's no color change. It's still in its particle size. So for that, you can put a relatively high melting point. Alright, so now another test to kind of compare both salts and sugar, or covalent and ionic. We are going to look at the electrical, or how well it conducts electricity, or the voltage that it has. So first off, I'm going to put some sugar in this cup, or not, sorry, salt. This is salt in this cup. Mix it with a little bit of water. We are going to turn this on. We'll do 20. So we're going to put both ends into the liquid and see what number it changes to. Around 165, 17, so around the 1700s. Okay. Go ahead and rinse this off. And now I'm going to put sugar in the cup. Mix it with a little bit of water. And do the same thing. You notice that the number doesn't change at all. So the salt water, if we go back to that, we notice that it jumps up to the 1500s or 1600s. So it is conducting electricity. So in your chart, you could put that salt does conduct electricity very well, whereas the sugar did not. It's not showing up anything. Alright, so now that we have our base for covalent versus ionic, with salt being the example of covalent, ionic being the example of salt, or sugar's covalent, salt's ionic. Now we're going to do it with the unknowns. First, we will check the boiling point of these and compare that, and then we will go and do the how well it conducts electricity. Alright, so I will do 2 at a time, just like how we did the sugar and the salt. Unknown 1 will be placed on the left side. Unknown 2 will be placed on the right side. Go ahead and light the Bunsen burner. You notice number 2 is already starting to sweat around the edge and starting to bubble, whereas number 1, nothing's really happening. So using that information, for number 1, you could put rather relatively high or low, and number 2, put relatively high or low. I'm going to put unknown 3 on the left side and unknown 4 on the right side. Go ahead and light the Bunsen burner. So you can see number 3 is actually already melting and bubbling, whereas number 4 is not really having much of a difference at all. Well, now number 4 is starting to melt a little bit as well. So they're both melting relatively low. 3 is so coarse it's like making popping noises, whereas number 4 is just slowly melting around the edges. So use this information to fill in the melting point for unknowns 3 and 4. This one is number 3. That one is number 4. Turning the gas completely off. Alright, so now that you should have filled in the relatively high or low melting point for both or all 4 unknowns. Now we are going to see how well each of them conduct electricity. So unknown number 1, put a little bit of water in there. Stir it up. When we stick this in here, you see it's about 1790. So use this information to fill in the, does it conduct a lot of electrical charge for unknown number 1. Unknown number 2. Putting some water in there. So it's conducting a little bit. It's not nearly as high as the others. So use that information to help you conclude what you should put in the blank for unknown number 2. Unknown number 3. Alright, so that's about what it's reading for unknown number 3. So you could draw your conclusions from that to fill in that blank. And then unknown number 4. So that's what it's reading for number 4. So you could draw your conclusions about 1, 2, 3, and 4 based off the melting point, or how quickly they melted, and based off of what this read, if it conducted electricity. So on your digital notebook, you will need to conclude, put the relatively melting point, or if it conducts electricity. And you'll need to answer the conclusion questions as well, and figure out if you think unknown 1 is ionic or covalent, and your reasoning as to why, or if it is uncertain if it is ionic or covalent. If you have any questions, let me know, and I hope you have a great day.